We're going to go ahead and take a look at number 47 from section 1.6, which deals with polynomial and radical equations. So for number 47, we are provided that we have a cubed root of x cubed plus 7 is equal to x plus 1. So one of the first things that we want to do is we want to attack that root that is encasing that x cubed plus 7. So a common error that I think that you should note is that sometimes people like to go ahead and break that root so that it's just the cube root of x cubed plus the cube root of 7. And I want to let you know that that's a huge error that you want to avoid, because x cubed plus 7 at this point, it's a comboed number. It in and of itself is one big number. I can't break apart a sum underneath a root, so I have to keep it bound together. So I have to think of a different approach. So what I can do, though, is I can take both sides and I can undo that cubed root by cubing both sides. Remember, equations are all about balance. They almost have the word equals within its name. So what I do to one side, I must do to the other. And what this is going to go ahead and do is it's going to allow me to free that x cubed plus 7, and this is going to be equal to x plus 1 cubed. Now, again, x plus 1 cubed, I bet you can guess what the common error is. Sometimes what people will do is they tend to just say, oh, this is x cubed plus 1 cubed. And what you'll actually discover is that this is leaving out a lot of the actual value from after you were to perform this multiplication. So I'm going to go ahead and do an aside. In other words, I'm going to kind of take my thoughts and my calculations and all of my dirty work, and I'm going to take care of it on the right-hand side of the screen. So here, I'm going to start off with that x plus 1 cubed, and I'm going to note that x plus 1 cubed is the same thing as x plus 1 times x plus 1 times x plus 1. And I'm just going to actually have this massive foiling party. And I'm using party because then it makes the idea of having to compute all of this so much potentially less painful. We'll go with that, okay? So I'm going to go ahead and FOIL x plus 1 times x plus 1. So I have x squared plus x plus 1. And I'm going to continue to keep that bound, because I still have to FOIL it with that other x plus 1. Before I do that, I'm just going to consolidate my work down. So I comboed those two terms because they are like terms. So now I'm going to go ahead and FOIL this out. So now I have x cubed plus x squared plus 2x squared plus 2x plus x plus 1. And again, we'll go ahead and clean that up again. And now that I'm done with that, I'm going to go ahead and plug it back in. I'm going to resume my work. So this is going to give me x cubed plus 7. Nothing's changed on the left-hand side. But again, if we were to FOIL x plus 1 cubed, that would give us x cubed plus, whoops, I hope you guys caught my error. That should be a square right there. Plus 3x squared plus 3x plus 1. So now, again, feel free to use your intuition with these problems, okay? Don't necessarily kind of default to a set amount of steps. In order to actually have a good understanding of how to solve problems, you do need to get messy. You do need to use your intuition to kind of figure out, just as it is important to find the correct pathway to solve a problem, you also kind of need to be aware of the pathways that you need to steer clear of. Okay, so I would say, first off, let's subtract an x cubed from both sides. Okay, this is going to, fortunately, clear them out. So now we have 7 is equal to 3x squared plus 3x plus 1. What is that starting to look like to you? And while I do that, I'm going to throw a couple other questions at you. What is the degree that you're noticing on that polynomial on the right-hand side? And what do we call those? And hopefully a word that starts with Q, ends in quadratic, might be coming to your mind. So we're going to subtract 7 from both sides. And notice that we still have this quadratic. Okay. So now we can go ahead and do a little bit more work. We can actually, why do I always do that? That should be squared. Sorry about that. Just goes to show you that even someone who has a background in mathematics can still make weird, strange calculation errors. So what I do notice here is that each of the coefficients, they are factors or multiples of 3. So what I'm going to go ahead and do is I'm going to pull a 3 out from each term. So this is going to leave me with an x squared plus x minus 2. The 3 is actually unimportant to us because we want to solve for the variable x. So we're kind of done with it. But the nice thing is by factoring out the 3, it's shrunk down the quadratic that we have to work with, which means it'll make it easier for us to factor it down. So if we go ahead and factor it, first off, I can see that I have an x squared, so I can break that into x and x. Also note that you have a subtraction sign here, but an addition sign here. That's going to tell you that the signs will be plus and minus. And lastly, let's focus on this 2. How can you break apart a 2 and so obviously 2 and 1 are the only multiples, or only 2 factors that would multiply to give you a 2. But we need to decide, should the 2 be positive or should the 2 be negative? And this is where the middle term kind of comes in. Notice that the middle term is a positive number, so that would tell us that our bigger factor should take residence there. Okay, and this is equal to 0. Again, we can say, well, x plus 2 is equal to 0, or x minus 1 is equal to 0. So now we can solve these simple linear equations. Subtract 2 from both sides for the first one, and add 1 to both sides on the second one. So x will be equal to negative 2, or x could be equal to 1. And of course, in these situations, what I would encourage you to do in order to avoid extraneous solutions would be to check your work. So let's check with negative 2 first. So we have the cube root is equal to negative 2 cubed plus 7 is equal to negative 2 plus 1. Make sure that when you are checking your work that you are putting it back into the original problem, okay, before you do any sort of manipulation to it, okay? So from here we have the cube root of negative 2 cubed would give us negative 8 plus 7 is equal to, well, negative 2 plus 1 is equal to negative 1. Cube root of negative 8 plus 7 would give you negative 1 is equal to negative 1. And the cube root of negative 1 is negative 1. So this checks. Now let's go ahead and try x is equal to 1. So we have the cubed root of 1 cubed plus 7 is equal to, sorry, I got a little over emphatic with my radical here, is equal to a 1 plus 1. So then this gives me the cube root of, well, 1 cubed is going to just be 1 plus 7, and that's going to be equal to 2. This becomes the cube root of 8 is equal to 2, and the cube root of 8 is 2, so this also checks out. So both of these are solutions. Okay, so there you have it. If you have any other questions, please feel free to either consult a tutor or come see me, and I'd be more than happy to help you out.